While Windows storage spaces provides excellent data resiliency, protecting your operating system's reliability is equally important. Typically, OS redundancy is achieved using a hardware RAID controller with a RAID 1 configuration. However, hardware RAID isn't always an available option. In these scenarios, Windows Server offers a built-in software solution, boot partition mirroring. Yet, there's an extra layer of complexity when dealing with modern UEFI-based systems using GPT disks. Here, we will tackle that complexity. Open an administrative terminal or PowerShell session and disk management. Although we will be using DiskPart, disk management makes some tasks easier. Also, disk management will visually reflect anything we do in DiskPart. In the terminal, type DiskPart. List the available disks. Select the current OS disk, which is typically disk 0. List and take note of the partitions. We need to assign temp driver letters to our EFI and recovery partitions. Select partition 1 and assign the driver letter A. Yes, A. We're also going to use B since we don't use those anymore. Select partition 4 and assign the driver letter Q. List the volumes to verify the driver letters. Select the secondary disk. Bring the disk online if necessary. Reset the read-only attribute if necessary. Convert the disk to GPT. List the partitions. We have to delete this reserved partition that was automatically created when we converted to GPT, but we will recreate it. Select the partition. Since this is a special reserved partition, we have to use the override switch to delete it. Create a 100 megabyte EFI partition, format it as FAT32, and temporarily assign the drive letter B. Now, we recreate the special reserved partition. Things get interesting here. Create a primary partition, but we'll have to remove it later. Now look at disk management and notice the size of the recovery partition on the primary OS drive. Shrink the new partition we created by the same amount, minus 1 megabyte. Create another primary partition. Format this partition as NTFS, assign the temp driver letter R, and set the partition ID and attributes. Open another terminal tab or session. Since we already have a working recovery partition on the primary disk, we're just going to robocopy the contents from the Q drive to the R drive. Using disk management, right-click Disk 0 and select Convert to Dynamic Disk. Check the checkbox for Disk 1 also. Click Convert and acknowledge the informational dialog box. Notice the color of the volumes turned to baby vomit green. On Disk 1, right-click the raw volume and select Delete Volume and acknowledge the warning dialog box. The area should show Unallocated with a black bar at the top. On Disk 0, right-click the C volume and select Add Mirror. Select Disk 1 and click Add Mirror. The volumes will now have a red bar at the top and will display the status Resyncing. Disk 1 will have a caution symbol as the drive sync. Be patient and wait for the sync operation to complete, and do not close the terminals. After the sync is complete, return to the terminal. Enter the A drive and navigate to EFI/Microsoft/boot. Enumerate the BCD for your awareness. Make note of the Windows Boot Manager entry. Copy the Boot Manager entry. The description you select is arbitrary, but make it meaningful. Note the grid provided. This is very important. Set a new boot entry using the new grid pointing to the B drive, which is the UEFI partition on the secondary disk. Enumerate the BCD using the All option, and notice the new entry containing the grid and B partition with the description we provided. Export the BCD setting to a file named BCD2. Robocopy the contents from the A drive to the B drive. On the B drive, rename BCD2 to BCD, and on the A drive, remove BCD2. That's it. Reboot the server. At the Windows Boot Manager screen, select Windows Server. This option boots from the primary OS drive, disk 0. Reboot again and select Windows Server Secondary Plex. This option boots from the mirrored secondary OS drive, disk 1. Log in and open Disk Management. Both drive 0 and drive 1 should show as healthy. However, if they show as resyncing, that's okay. For this test, I'm going to remove the primary boot drive to simulate a failure. At the Windows Boot Manager screen, when Windows Server is selected, an error appears. When Windows Server Secondary Plex is selected, the system boots from the secondary OS drive, which is now the primary. Log in and open Disk Management. Now, the mirror status reflects as failed redundancy. Now, I'm removing the secondary boot drive to simulate a failure. At the Windows Boot Manager screen, when Windows Server Secondary Plex is selected, we have a different failure, but still a non-boot. But this time, when Windows Server is selected from the Windows Boot Manager, the system boots. Log in and open Disk Management. Again, the mirror status will reflect as failed redundancy. To reestablish the mirror following the replacement of a failed drive, open Disk Management. Right-click the C volume and select Remove Mirror. Select the missing disk, click Remove Mirror, and acknowledge the dialog box. At an administrative terminal or PowerShell session, type disk part. List the disks to ensure you're working with the correct one. The remaining steps are the same as when first establishing the mirror. I hope you enjoyed this video, learned something new, and found it useful. If you have any feedback, corrections, or suggestions, please let me know in the comments below. Please like, subscribe, and pass it on to others. And I thank you for watching.